Okay, can everybody hear me okay? Just checking that everything is up and running properly. Um, okay, I'm going to assume that people are seeing this okay and that people are hearing this okay. If anybody's got any comments, thoughts, anything else, you can put them into the YouTube chat or the WhatsApp chat. I will be watching both of them. If you guys are watching, drop a comment in YouTube so that I know kind of what my stats are at the moment, because I can't actually see how many people are watching, etc. And I'm just going to be hoping that this is working okay. Okay, so what I'm going to be doing tonight is the start of writing something which is basically a BGP LS client. Now, BGP link state is a routing daemon. It uses TCP and shouldn't be that difficult to get up and running. And yes, I work with JetBrains IDE because, quite frankly, when you're doing a large project like this, along with its remote development capabilities, it works pretty well. Now, I've already created a project in this. The first thing that I'm going to need to do here is I need a CMake file. The thing is, when you're doing any large project, and by the time this is done it's going to be pretty large, you really don't want to be just doing it all in a single file, so you want a decent kind of CMake file that you can build on. And quite frankly, CMake is just cool. So let's start there. We're going to be using 318, which is what I typically use. We're going to call this BGPLS. We're going to set C standard to 99. And I'll explain some of the flags that I typically use. O3, get the compiler to optimize it. G3, so that I've got my debugger. And that no address of packed member is because I'm going to be using packed structures at some point, and I still need to be able to take pointers to members of the structures. Effectively, when you're writing in C, normally the compiler will pad your structures to memory alignment boundaries unless you explicitly tell it to pack a structure, in which case there is no padding. But that can create compiler warnings when you start trying to take pointer references to things inside packed structures, and can cause you a little bit of headache. So I'm just going to tell the compiler to pretty much ignore that. By the way, if anybody's got any questions as I go, please just put them in the YouTube comments or alternatively in WhatsApp. Next thing, I'm going to add an executable. Now, this I'm going to add an executable for main.c, and we'll start with tcp.c. Main.c I'm going to create purely just as something to run what I'm doing. tcp.c is going to be the start of it because I'm going to need to create a effective server here. I try and keep my main to basically a bare minimum, and put everything in separate files where I can easily find it. It makes it a lot easier for large projects. Then I'm going to go and create main.c. I don't need an associated header, and I'm going to go and create a new source, tcp.c. This one I will need a header for, and at that point you'll see that my project is saying that it's not configured yet, and I've got an error with my CMake minimum required because this should say version, and if I reload this I've got a clean CMake file. At that point I've got my main.c, I've got my tcp.c, I've got my tcp.h. Now when I'm building TCP, typically speaking, TCP has sockets, it has address length, it's got the socket address, it's got the socket itself. And because this is multiplexed, okay, so let me answer that quickly. Why the preference of CMake over Make? CMake is 1,000 times more powerful. It allows me to do stuff like doxygen. It allows me to do a lot more conditional compilation a lot more easily. CMake is really, really powerful, and it's just easier and cleaner than Make as well. You can actually use CMake to generate Make files, or you can use CMake with something like Ninja. You can use CMake with Meson. So CMake just more flexible, just better. I hope that answers the question. As I said, with regards to TCP, there are a bunch of things here. So we'll start with a header, because when you're creating stuff for TCP, I prefer, where possible, to define my header structures before I start actually writing code. So we'll start, and we're going to need a socket structure. Now, socket structure, the reason that I do this is because I'm going to be making this thing to work with both IPv4 and IPv6. Sock ADDR in v4 struct sock ADDR v6 v6, and before I can do that, I need to include a whole bunch of stuff here which I'm going to need for later. I'm going to need my timing, I'm going to need H, I'm going to need socket H, I'm going to need types, I'm going to need netdbh, I'm going to need standard boolean, I'm going to need UNSITD, I'm probably going to need generic typing. This next one I'm going to use the DPDK spin lock library because it's just, well, easier than trying to write my own spin lock right now. Other thing I'm going to need, this import is 179. Trying to think if there's anything else I need. Okay, I don't think so. That should do. Because a socket can't really be V4 and V6 at the same time, well, it technically can, but best to just put them into a union so that you don't use more memory than you need to. You need to be able to store the length of the address of the socket. Now keep in mind that because a V6 address is much longer than a V4 address, you can make the socket address the V6 length and you'll have enough space for both. And then you've got your socket itself, which is just an integer. So that'll define your actual kind of TCP socket structure. Then I'm going to need sessions. So a session is an actual TCP session that is associated with a socket. So that will contain my socket structure. We probably want to create a client as well. That differentiates between server sockets and client sockets, because this thing technically will be able to do both a active and a passive session, which is why I will add a boolean there. What I mean by an active session is I am connecting to the router. On a passive session, the router is connecting to me. I need to be able to differentiate those because in BGP, the way the protocol works is there is a different handshake sequence dependent on who establishes the session. This is also BGP based, so I need to put timers in here for next retry. I want to know when the session was established. I want a receive buffer. We'll call that rec buff. Going to find buffer size up here. Maximum NTU on a normal Ethernet connection is really unlikely to be over 9200 bytes, so we're just going to call that 9200 and be done with it. We're going to create a send buffer that will also be 9200 bytes in size. Now there are a couple of ways that I can build a TCP server. In this particular case, I'm probably going to thread it, so I will add this. If I decide not to use the threads later on in the code, I can always just delete this. Then I want to make this a double linked list. Makes it easier to find, delete, remove sessions. And I'm just looking to see if there are and I'll add a boolean that'll allow me to signal if this thing is done or not. Then let's see. Okay. So I've got my structures defined. It's worth actually splitting this just so that I can keep track of what I'm doing. Has anyone got any questions about what I've done so far? Pretty standard struct definitions, etc. WhatsApp or YouTube, otherwise I shall continue. Okay. Okay, so the first thing I need to do if I'm creating a TCP server is to create a function that is effectively going to listen on the thread. Will listen for sockets. Now, the first thing that I'm going to do here is, because I'm probably going to be threading this, my function definition has to be of a void type, because pthreads require void type functions. Let me just double check that before I lie to you all. Yeah. So now that handler is, as you'll notice, is a void. Now I probably need a handler struct as well there. So let's see. So the thread handler structure is basically there so that I can effectively read information about all my threads outside of my listener, etc. And first thing I do is put the thread handler is also basically, by the way, going to be largely global. It will be passed from main. I put the Boolean shutdown in there because it allows me from outside of the thread to set that and effectively shut down the whole damn program without a hard break on the thread. Then I am going to put a struct, and I'll explain what this neighbor is in a second. It's a BGP kind of specific structure I'll create now. And then I want a neighbor count to know how many neighbors. Neighbor thread, neighbor structure would look something to this effect. Just double checking something quickly. You would have a peer IP, which we're going to make as a char for now. You'll have a local IP. So this will be the IP of the router that's allowed to connect to me, or that I and yes, it's being recorded for the guy who just asked me in WhatsApp. Basically, with BGP, you have your peer IP, that's the router you're connecting to or the router you're connecting from. Your local IP is so that if you have multiple IP addresses on the box that you're working on, you know that you want to listen from a specific IP. BGP also requires that you declare what your router ID is, This again is normally in the form of an IPv4 address, so we'll just make this a 255 character string just so there's plenty of space. You'll also have your local autonomous system number that again is BGP specific, and I'll explain it when we get there. You'll have your autonomous system number of your peer. Then things get a little bit more complicated. I'm just trying to think of the best way to do this. We're going to make this a single address family and a single sub-address family. Again, these are BGP terms. Let me add a comment in here. So all of this stuff is derived from the BGP standard, which is RFC 4270. I think it's RFC 4271. Let me just verify that. Yeah, RFC 4271, which, by the way, I can show you what that looks like. Let me just see if I can. If the screen goes blank for a second, it's just because I am about to see if I can add this. No, that's not letting me do that. Okay, not a problem. But anyway, you can go and look up RFC 4271 and it's available. Let me add it to the comments actually. That one over there. So that's a basic neighbor. We also want to allow somebody to shut down the neighbor. We want a keep alive time because BGP requires that I send keep alives. And these two I'm going to comment out for now because I'm not going to define them straight away. But I know that I'm going to need them kind of later on in the game. Basically, with BGP, because BGP, when you're receiving the packet, they don't always arrive aligned. So you almost have to put this through another queue so that you get correctly aligned packets. Otherwise, things are going to break pretty badly. Then so we have our thread handler. Now keep in mind that because I'm passing this in as a void, to be able to use it at all, I'm going to need to cast it. So struct thread handler equals handler. That basically just make a pointer to the same void pointer so that I can easily access it effectively. Then I need a res. That's basically a result structure. Then I'm missing something here. TCP listen. You'll see that I created my sessions here, but I also need another structure called TCP listen, which has my main listening socket on it, my main server socket, a list of connected sessions. We'll track the last session in the list because it just makes it easier when I'm adding new things, and put a spin lock on it because I don't really want to screw with that link list on the session list without having things locked, because if I do that I'm going to create problems. Then okay, now it just creates me a basic variable on so that I've got something to compare with, etc. Then start spec sleeper 0 TV NSEC 500,000. Basically that'll just give me a half a second time for when I need to sleep, and that's because some of these functions don't take time spec. We'll add a time val TV equals 0.50. So the difference between this is in nanoseconds and this is in USECs, which is, yeah, I may not need one of those, but I'll define them both anyway for now, just in case. And I can always delete them later. Then I want my basic session, and then the first thing that I want to do, so listener, if you look, where did I define that? Struct TCP listen listener calloc 1 size of allocate that, if not listener. So if the calloc fails, then listener is automatically going to be null, so I can just say that, and what I tend to do when I'm printing error logs when I'm coding like this, and I can always go back and change it, is I tend to print the name of the function that's called it so that I know where that debug log comes from. And try and make the logging messages such that if I'm hitting an error, I know where the log came from and I can jump to the right point in the code. Just makes things easier when you start running, etc. Listener. Now this here is going to return a standard error, so just make this nice and clean. I'm gonna, for now, just expand this a bit so that we can see. And then I'm going to return null. Now, I could technically return a structure with more errors in it from the thread, because the thread is a void pointer type, so I can return anything. But because this is just my listener, I'm already printing an error, I don't really need to return anything else, so I'm just going to return a null on this one. Now, because I want this thing to listen on both V4 and V6, if I listen on an IPv6 family, I can actually listen for both at the same time. So if I do this, now it's interesting, the client doesn't pick this up, the IDE doesn't pick this up terribly well because of unions, etc., but it does work. This is AF INET 6 server. Oh, that's why. Sorry. Syn6 port. Now, in networking, everything is working in big endian. So, if you look back at where I defined this here, I did a definition of port 179. Keep in mind that that is in little endian order because this is a UN16, and so I have to swap this. Man, what am I doing? Yes, Charlie, I do not use malloc because malloc does not zero allocate. Charlie just commented in the WhatsApp that I prefer to use calloc instead of malloc. Anybody who uses malloc while calloc exists needs to be shot, because calloc will zero initialize, and allocating memory that isn't zero initialized can lead you to all sorts of problems. So for the love of God, please can people stick to calloc rather than malloc. And sorry about the fan noise, it should shut up in a second. It's just my router decided to wake up and get grumpy about the heating here. Shut up. Sorry about the background noise. I'm trying to think what I can do about it. Not much. Can you guys still hear me okay? Am I still audible? See if I can play with the gain a bit. There we go. It shut up. Okay. Then server v6 syn6. So effectively, I'm telling it now that in680DRNE will allow it to listen on any port on any address bound to the box when I create the socket. Then I need to create a listener socket. 6. This is a streaming socket because I'm just going to get streaming data in from the socket. Test it for an error. TCP listener. And bail. Basically, if I can't create the listening socket, I'm done. Then typically when I'm working with sockets like this, I will set certain socket options on this thing. This is a socket. and SO reuse address ampersand size of 1. Basically, the reason that you do this is because when a TCP socket, when you close the application and have to restart it, some of the time it takes Linux kernel a little while to release the socket. This will basically allow the socket to be grabbed again so that you can restart the application without your socket being in a thin wait or a reset wait state, which can end up with you not being able to restart your application for a couple of minutes until the kernel decides to clean itself up. That creates me a network socket up until this point. Now, the next thing I have to do is tell it that I actually want to listen on the socket. So, listen LSOC, and I want to know how many sockets I'm prepared to kind of queue up before I accept them. I'm just going to say that I'm going to allow for 10 in my queue, and printf TCP listener failed to listen to bound TCP socket. Man, my typing is terrible this evening. And I will bail if I can't do that. Now, I've created my socket, I've listened on my socket, and okay, so I just got asked what I'm trying to do with the code. Joe, I'm effectively writing a BGP daemon to get and receive routing information from routers using the BGP protocol. This first part of the code is me doing the TCP work to effectively create a TCP server that is at least vaguely resilient to errors, etc. I hope that answers the question. Now, you guys will remember that when I created that handler structure, I put a shutdown boolean in it. Keep in mind that this listener thing is running in a thread, and I need to be able to actually tell this whole thing to shut down in the event of me hitting Control C or whatever. Oh, here goes my router again. Sorry for the noise, but let me continue anyway. So effectively this is saying while that shutdown is not true, keep going. Then I'll explain this in a second. So effectively this polar here, what am I missing here? I put an error over here. Let's just see what that is. Base type void. Oh, because remember I passed in handler, so I'm actually using HNDLR over here. HNDLR. and this should be a poll FD. And the other thing that I forgot here is that I need to I'm just checking something. And I'm also going to need to include into here there we go. Some of this polling stuff requires GNU source because I'm using certain GNU source specific functions, so I have to define this. The IDE tends to bitch and whine that it's never used, but it is actually used because it actually tells the thing to compile with GNU source, so just ignore that. Then close that down there. So basically I am creating a polling structure which I'm going to use to poll for new connections effectively. And then I'm going to simply did I define a reply code? I'm not quite sure why this thing is whining, but it's whining, but oh well, we'll ignore that for now. Now, this is basically polling the socket that I'm listening on to effectively say, is anybody trying to connect to me? And it's got a timeout. The reason that I put a timeout here and don't just let it hang around waiting for it to poll is because if I hit Control C or something, I wanted to test this while loop. So I'm just going to tell this thing to keep timing out, and then it'll just keep polling once it's finished timing out. There is only one file descriptor in the poller pointer here. That's why number of file descriptors is set as 1. You can actually create an entire array of pollers as a pointer array, and then you can listen on multiple sockets at the same time and poll them at the same time. I'm only using one at the moment. Test the return code. The return code is what poll will put in this thing, and I'm basically testing it to check whether or not I got a response from an inbound poller, and I can continue if I didn't get that and I got some other event. Then I want to switch on the reply code, and we can say printf this will be sockets basically if I get an error off that polar on this particular socket, I've got a problem and I probably should just bail because something's gone really, really wrong. Otherwise, I will get a 0 return code, in which case the 0 return code basically means nothing answered, I got no input, I got a timeout effectively. And then I'm just going to repeat my loop. Otherwise, I'm going to go into a default case, and the default case, I'm just trying to think here. Let's do this properly. So we're going to call something here called call locked, and I'll explain this in a minute. Okay, now first thing is that you'll see I'm getting a bunch of errors here because I haven't defined call locked and I haven't defined TCP accept yet. Call locked is gonna look something like going to go back to our header file here, and you can generally put this at the bottom here or at the top. It depends on your coding style. I'm just going to throw it in here for now. Lock. Right. And let me just see what I've missed out here. Because this is a macro, I have to escape every line. And effectively, what this simply does is a fairly simple macro that basically will lock my spin lock, call a function, get a return value, and when the function returns, it will unlock the lock again, and then the macro will return the result that the function gave me. The reason that I do this as a macro is because if you forget to unlock or lock something at the wrong time, you can create race conditions which can be a real pain in the ass to deal with and to find. Just to everybody on the stream, does everybody understand that macro, or can I give some more explanation? Speak now or forever hold your peace. WhatsApp, YouTube comment, whatever. I'll give it a couple of seconds so that I know that everybody is caught up, because I don't know how lagged the stream is. And if you do get it, say something so that I know that people have actually heard this. Okay, so Franklin, have you ever worked with C macros before? Basically, you need to think of a macro as effectively what it is, which is a code substitution. So in C, if you define something like I have there as a macro, effectively what happens is it does a replace on the code. So if I'm lucky here, it's not actually showing me the replacement values. But this call locked will effectively get replaced by this piece of code. So effectively what you will end up here is over here, that func is getting replaced by TCP accept, as well as anything inside the brackets of TCP accept. So the first parameter here is equivalent to this whole thing over here. Lock is the equivalent to my second parameter. The next line, this void return, is because I need to effectively define a variable inside this replacement code block. The macro will then call the lock against this here. Now, parameters to function macros need to be bracketed like this, which is why I've got extra brackets here, and I'm making it a pointer because I need to actually lock a pointer here. This will then effectively call this first parameter and store the return value in this variable. It'll then unlock this lock over here, and this final line here acts almost as a return for whatever I've got in this variable. I'm hoping that makes sense to everybody. Any specific questions on that before I move on? Because you'll see that I use a fair number of macros like this as I go, and it's kind of important that people understand this. So if you've got specific questions, please speak now in the chat, etc. In the meantime, okay, I'm going to continue and I hope that people grasped that bit. The next thing here is that you'll actually see here that it's moaning that I have an undeclared function of RTE spin lock. That's probably because I don't I probably need to include the reason that the I'm trying to figure out why it's not allowing me to call that, and I'll show you something else in a second. Oh, that would be why there was an error, and I can actually get rid of this over here. There we go. Yeah, that's fine. So that error is now gone, but I've still got an error. Now, the funny thing is, because of the macro substitution, if I look at my errors here, I start seeing errors all on my line 59. You don't actually see a lot of those errors on line 59 because it's going to treat this whole macro as line 59 in the code. So it does get a little bit of a pain in the ass to debug some of these macros sometimes, to figure out where the error actually is in the macro, but it is what it is. you'll see there, for example, it's saying incompatible integer to pointer conversion type. The reason it's saying that is because my TCP accept function doesn't exist yet. Ret is defined as a pointer. The default return for a non-existent function would be an integer, so therefore throw a warning. That, however, will change the moment that I go and define this TCP accept function, which I'm going to do right about now. Now, the other thing about the TCP accept function, I'm never going to be calling TCP accept from outside of TCP.c, and I don't really want anyone to do that, so I'm going to declare this as a static. What am I doing? Let me just expand this a bit because this is quite a long function definition. Handler TCP listen. And I'll just put a default return. The reason that I've done that is just to show you that suddenly down over here, the moment that that function is defined, I no longer have an error on my TCP accept because it's accepting it, and my macro itself is now functioning because it can see it. But I've still got an error on session handler over here, and that would be because I didn't actually define my session handler. Let me check something. Okay, so this pthread create is going to call another function called session handler, which will actually be my main handling session. So what I'm going to first do is I'm going to accept it, create a session, and then pass it to my session handler. So I can actually comment that out for now, and you'll see that I've got no more errors in the code up over here. But first I need to create the TCP accept function. The TCP accept function, we're going to go and define that up here. So the first thing I need to do is create a socket structure. TCP socket. It helps if I don't make typos. I'm going to need to tell it I need 6. If not so, and if, again, telling it what function I'm calling this in, 8 for TCP socket, so if I can't allocate for the TCP socket, just bail because something broke. But it doesn't like that, so I have made a typo over here, and that's okay. just want to make sure that I typoed something. Oh, here we go. So that will allocate for the TCP socket. Now, remember I said that I'm accepting this on both V4 and V6. So I effectively need to know now whether or not this is a V6 or a V4. And I'm going to kind of cheat a little bit here. So firstly, I'm going to go and get the peer name. Let me just collapse this. Actually, you know what? I can collapse that. SOC V6. You'll notice that I do a lot of error printing in my code. I do that because, believe me, it's easier than not having an error at all. The next thing that I want to do here, and I'll explain this in a second. So effectively, the IPv6 address is normally treated as an array of bytes, but I need to know things about this in its various components, which are going to allow me to tell whether or not this is effectively a V6 address or a V4 address. And I can do that by effectively casting parts of the address into various bits and pieces, which you will see in a second. So I know that if this is a V6 address, then the first part of my V6 address, the first UN64, is probably not going to be all zeros. Neither is the second UN16 here. And the third is going to be like that. That will effectively tell me that if the first 10 bytes of the V6 address field are all 0 and the next 2 bytes are set at 0xFFFF, that is going to be a IPv4 address encapsulated in an IPv6 format. I believe that that is defined in RFC 4291. If not that, it'll be RFC 8200. But effectively, this will tell me if it's a V4 or a V6 address. If this is a V4 address, I need to change my family to AFINet from AFINet 6, which is the default that I've got up here. And my v4 address will then become a 32-bit of 680 or 12 and AFINET IPv4 address. So effectively what I've said here now is, if this isn't a v6 address, get the v4 address and then use it to populate my character string up here with whatever the hell that address actually is. And then just for good measure, I can print something to tell me that I've got it. Otherwise, I'm going to tell this thing ntop AFINET 6 680 address INET 6 address and FTCP session dot IPv6 address. And that will effectively now get the name that the socket is coming in. It'll get the address of the socket that's coming in from. Now, normally, if I was writing this and I wasn't doing this, hold on a sec. I apologize if this is more than rocket science, Franklin. Is everybody else following along here, or should I take a bit of a break and continue this a little bit later? What would people prefer? Please let me know in the YouTube comments or on WhatsApp. I've had a request to kind of take a break possibly until tomorrow so that people can digest all of this so far. Thoughts, will go with the popular opinion. Okay, I'm going to take a break for today. I shall come back. I shall leave this exactly where we left off and people can check it out, etc. And I will do part 2 of this tomorrow evening. So I hope that was useful and we shall continue tomorrow. Thanks very much.